Okay, welcome to part one of a four-part series on fat loss with exercise. Today we're going to be talking about some of the basics of the regulation of fat metabolism. So, adipose tissue is a storage depot for triglycerides, but it's also a complex endocrine organ releasing a number of peptides and other factors that can act in an endocrine or a paracrine fashion. And I have to emphasize that because so many people think about fat metabolism as, or fat or adipose tissue as simply a storage depot. I have to emphasize that it's more than that. It is a very complex endocrine organ. If you understand that, you can understand why gaining or losing fat can have such an impact on overall health. With high levels of obesity, that could have negative impacts on health, possibly increasing the incidence of type 2 diabetes. Whereas if you have diseases where you have an absence of fat, that also can cause serious problems like diabetes. So the other thing to understand is the sort of remarkable plasticity of fat tissue. We spend so much time on skeletal muscle hypertrophy with athletes, but we see that hypertrophy is so limited, in our ability to gain muscle. Whereas adipose tissue seems to be limitless. That basically adipose tissue can range from anywhere from 20 to 28% on average in men and women, but can exceed 80% in morbidly obese individuals. So this is really crazy in its actual capacity for growth. Now, fatty acid uptake into tissue is dependent on lipoprotein lipase activity in adipose and muscle. So there's a concept known as nutrient partitioning, which we've talked about before in the sport nutrition course. But what determines whether fats that are in your blood go to muscle or adipose is going to be largely dependent on this enzyme called lipoprotein lipase. So essentially, fat's carried around these large fat globules called chylomicrons, and as they circulate through the blood, in order to cleave off fatty acids from these chylomicrons, either into adipose or into muscle, you need an enzyme called lipoprotein lipase. So, as the name suggests, it will essentially cleave off fatty acids from this chylomicron, and that is where nutrient partitioning again comes in. What determines whether the nutrients go towards muscle or fat? That's part of it. This enzyme here. So we can upregulate, for example, tissue-specific LPL, and we'll be discussing that later. Now we know that activity has a very large role in regulating our weight. In fact, weight gain 12 years and following middle-aged individuals is inversely proportional to activity. So you see here met hours per week, none, all the way up to 14.1 to 123. We see that the lowest weight gain in middle-aged individuals over 12 years' time is associated with the highest level of activity. Now, this study here had a control group, and then they had weight loss induced by dieting, which was here, weight loss induced by exercise plus basically weight loss, and then fat loss with exercise without weight loss right here. So basically what it's saying is that diet-induced weight loss, exercise-induced weight loss both increase fat loss. While exercise does more so than diet, if you look at exercise without weight loss, you still induce declines in fat loss. So basically what this is suggesting is that exercise alone can shift the composition of your body without actually changing the mass of the body. So one of the number one variables that we really talk about with exercise is intensity. And your ability to train at certain volumes is going to be dependent on your conditioning status. So here, to your left, we have sort of an untrained, not as lean individual, hurting right there after exercising. And if we look here, highlight this, he has a very low capacity when he's walking 4 kilometers an hour. His VO2 max is 35% when he hits 7.2 kilometers an hour, which is sort of brisk walking. That leads to 70% of his VO2 max. So it's not very fast. If we look at at his METs, okay, METs is basically how much calories you're metabolizing above resting. So one MET is your resting metabolic rate relative to your body weight. So he's expending 3 and 6 METs respectively. So 6 times his resting when he's at 70% VO2 max. However, we look at the athlete over here, slow walking is 17.5% of his VO2 max, and brisk walking is only 35%, whereas 75% of the untrained individual. Whereas it takes 11.5 kilometers an hour to get to 70%. Now, if you look at the METs at 4 kilometers and 7.2 kilometers, he's still using 3 and 6 METs respectively, even though intensity is relatively lower. But at 11.5 kilometers, which is 70% of his, he's actually 12 times above resting. So it shows you that with greater training status, you can actually expend more calories in a given workout session. So it does give sort of an advantage. One thing I want to emphasize is that changes in adipose tissue size are impacted by exercise. So what we know is that exercise, both low and high intensity, decreases abdominal fat relative to diet only. So here we're looking at diet only, changes in abdominal fat mass. That's diet plus low intensity exercise, and that's diet plus high intensity exercise. So basically, clearly, we have a preferential decline in adipose in the gut. We think that this may be due to a preferential lipid mobilization from subcutaneous abdominal compared to femoral adipose with exercise. To support that, we see here that when you exercise from basal 15 to 40 to 60 to 90 minutes, abdominal fat metabolism increases, whereas if you look at the leg, it doesn't increase that much. One of the reasons why we think this is the case is because direct sympathetic outflow within adipose is not uniform. So we think that sympathetic outflow may be greater towards the gut than the legs. Some regulators of lipolysis include your catecholamines, atrial natriuretic peptide, insulin, and growth hormone and cortisol. Another method where exercise impacts fat metabolism is this impact following an actual meal. So what we're seeing here is that triglycerides, for example, when you eat a higher fat meal, raise in the blood. If you look at the exercise compared to the control, triglycerides are lower following after the exercise session than the control. We think this is because the clearance or uptake of triglycerides into muscle is increased following long duration, moderate intensity exercise. So you can see triglyceride uptake following exercise compared to the control is much greater. Now, one thing you'll point out is that during exercise, your body, after 12 weeks of endurance exercise, 30 to 45 minutes, 4 days per week for 12 to 14 weeks, at 70 to 85% VO2 max, from pre to post training, if you look at the non-plasma fatty acids and plasma fatty acids that are metabolized, following training, we see that rises by 25% in total. So you start to rely more on fat and less on carbs. Everything we know is this is looking at lipolysis. So we know lipolysis is increased following 60% VO2 max moderate intensity exercise. So we see here, that's rest. See here, that's exercise. Now, one thing that drives differences in the ability to metabolize fat is the sensitivity of fat tissue to your catecholamines like epinephrine and norepinephrine. Specifically, we have alpha receptors and beta receptors. When epinephrine and norepinephrine bind to beta receptors, it will enhance fat metabolism. When they bind to alpha receptors, it will decrease fat metabolism. So, if you look during exercise at lean individuals, which is the black, what we're seeing essentially is, an increase, or actually, to the left, which is graph A. You look at the white, that's basically just exercise alone. And then the black is when you add what are called alpha receptor agonists, or antagonists. So if you administer an alpha receptor antagonist like yohimbine, for example, if you see in the lean individual, they do increase in fat metabolism. But if you look at the obese individual, they're not metabolizing any fat during exercise. When you administer the alpha receptor antagonist, they drastically increase in fat metabolism. This suggests is that in lean men that they likely don't have the same alpha receptor density or sensitivity as obese individuals. So, in other words, it's harder for obese people to lose fat. So let's summarize this lecture up. When you exercise, we basically see that lipolysis is increased. We also know that reesterification of fatty acids into triglycerides is decreased. Adipose blood flow and O2 delivery is increased. And skeletal muscle uptake of fatty acids is enhanced. And this remains for up to 24 hours. Some of the reasons we have increase in growth hormone, cortisol and epinephrine and norepinephrine, which we know all of those have these actual impacts on lipolysis and fatty acid oxidation. This ultimately may lead to long-term change in body composition. Thank you, and I'll see you on Fat Metabolism Part 2 later.